Okay, there we go. Hello, everyone. I was having some issues um, with the chat coming up, but looks like we are live now. Let me just open up another page just to make sure this is all looking okay on the viewers side of things. So. I'm going to be sharing my screen here in a minute. We're going to get started on some pre-algebra and algebra skills. So, as always, let me know if you're here. Say hello. There we go. Okay, I think that's looking okay. So we're going to go ahead and get started. Just a review of our live stream rules and community guidelines here. Also, some ways to support me if you're interested. And a like and subscribe is always great, is always helpful for me. So if you're here, say hello. And make sure that you like this video. That would be really great. All right, I'm going to keep an eye on the chat over here on my other screen, but otherwise we're going to get started on our pre-algebra first. So just like last week, I'm going to be trying to do these at this time on Thursdays every week. My schedule does sometimes change a little bit depending on what my students need. I do offer one-to-one tutoring. So if students need that time to reschedule or something, then that's when I'll try to update and let you know when we're going to be able to do this live stream instead of this regular time. But for now, it's going to be Thursdays at 4 Mountain Time, 5 Central, Eastern Time. So I thought that would be a good time when people are home from. We're going to be graphing linear equations. Last week we talked about how to find slope, so we're going to be using that skill and going on to the next step with graphing. I might switch next week. I might switch to transformation, so like rotations, reflections, translations, and dilations. I just with my students that I work with that are in pre-algebra, each school is different, so I'm trying to align what I'm doing here with what students are working on at school. So if you have any suggestions on that, then please let me know. All right. Let's go ahead and get started with sloping, not sloping, with graphing these lines that are in slope-intercept form. And we're going to start here, y equals 1/4 x minus 1. So when we're looking at these in slope-intercept form, the coefficient that's with x, that's going to be our slope, and the constant that's being added or subtracted at the end here, that's going to be our y-intercept. So it might seem counterintuitive, but that's actually where we're going to start. We're going to start at the end with that -1 or -1 and work our way backwards. So for our y-intercept, this is our y-axis, this vertical axis right here. So we're going to start off by just simply plotting our first point on that y-axis at -1. This point it shows that the line is going through the y-axis at this location. Now, for our second point, that's where we're going to use our slope. Our slope is going to inform us where to go, where to move to graph a second point. We need 2 points in order to graph a line. So our slope is 1/4, and we're going to hear this a lot, rise over run. So rise is how much you are moving up or down, so that's a vertical movement from our first graph point here. And then the run is how much we're moving right or left. So because both of these numbers are positive numbers, that means we're going to move up 1 unit and to the right 4 units. So actually this by drawing jumps here. So we're moving up 1 and then to the right 1, 2, 3, 4. And then that's where we're going to put our second point. A lot of students will make the mistake of putting a point here in the corner. We don't want to point there. That is just where we are changing directions from vertical to horizontal. And so all we need are 2 points. If you would like to graph more than 2 points, what we can do, we don't really have room to go up 1 and to the right 4 again from this point, but we can go down here. Let me change my cursor because I think that this is too let's go with, like, a darker color. Okay. Um, so as we can go down 1 unit and then to the left 4 units. And as you can see, this point do that a little better. This point is right in line with these other 2 that I have graphed here. And if you're doing this on paper, of course, you would use a straight edge, like a ruler, the edge of your book, something like that. You want your line nice and straight and going through all of those points and spilling off of the graph on both sides. And we do have a positive, just as of note, we do have a positive slope. So we are going up as we go to the right. So that does indicate a positive slope. So always check that just to make sure you haven't accidentally counted in the wrong direction. All right, let's go into problem 2. Problem 2 is y equals negative x plus 2. I wanted to make sure to include this one in particular because a lot of students get tripped up when they don't see an actual number in front of the x. So when we see a negative, then that is just a negative 1. When we don't see a number in front of any variable, it's an understood 1. So our slope is negative 1, and I'm gonna actually write that as a fraction as negative 1 over 1. This is one of those times where we actually want fractions. And then our y-intercept is at positive 2. So let's go ahead and start there with the y-intercept at positive 2. And then our slope of negative 1 over 1, that means we're gonna move down 1 unit and over to the right 1 unit. Down 1 unit, over to the right 1 unit, down 1 over 1. So as you can see, all of these are lining up in a nice straight line. And I do like to graph as many points as possible on the graph. And then we can go in the other direction as well, up one to the left one. And our line is going down and to the right. As we go to the right, it goes down. So that matches up with our negative slope. We talked about that last week. When we have a negative slope, it is pointing down as we go to the right. Okay, so we have graphed that, that linear equation as well. Let's go on down to these 2. I wanted to make sure to include these 2 because these also will trip students up quite a bit. So we've got y equals 4 for this first equation here, and then x equals 5 here. So let's talk about the y equals 4. Y equals 4, it might seem very different than these other equations up here. But what is really happening is that this is y equals 0x plus 4. So it really technically is still in that format. We just don't have an x term in this one because our slope is 0. Whenever our slope is 0, we're going to have a flat horizontal line. So, but our our y-intercept is still at positive 4. So I'm going to go ahead and mark that at positive 4. And then for our slope, where our rise is 0 and our run is 0. So we're not moving up or over. So that just means that we are going to have a horizontal line going right through where y equals 4. So those can kind of throw people off sometimes. But that is what anything that where we have y equals and there's no other variable, there's no x, in the equation at all, then you're just going to have a horizontal line at whatever that number is. So if this was y equals -3, then we would have put at a point here at -3, and then we would have a horizontal line there at -3. So it can be anywhere along this y-axis. All right, so that leads us into our last graphing problem of this type, x equals 5. There's no y involved at all, and that's because there's no y-intercept. So when this happens, this is not technically slope-intercept form. So when this happens, it's similar to this in that it's going to be a straight line, but this one's going to be a line. And this one actually has a slope. The slope for this one is undefined. Actually, I forgot I wanted to write specifically what the slope is for this one. The slope for this one is 0, and the slope for this one is undefined. And it works similarly, except now we're talking about the x-axis. So the x-axis is that horizontal axis. X equals 5, so we're gonna go ahead and put a point there at 5 on the x-axis. And then this is just a vertical line. Again, we're still going to graph it, spilling off of the edge of the graph, but it's just going through that, point of 5 at the x-axis, and as you can see, our line that we graphed is parallel to the y-axis. So, in this case, we have a slope that's defined, and that's how we graph x equals 5. If this was x equals -3, then again, we would put our point there at -3, and we would have a vertical line there at -3. All right, well, let's go on to more graphing, but these are in standard form instead of so our slope-intercept form is y equals mx plus b. Slope-intercept. Okay. Now we can always change a standard form equation into slope-intercept. We just have to solve for y. However, I picked actually, that's what we're gonna do for this first problem number 2 here. 10x minus 3y equals -15. We can tell that this is in standard form because we have the x term and the y term over here on the left-hand side of the equal sign, and then just a constant on the right. And the x term is a whole number, and it's a positive number. So those are the rules for it to be standard form. We can go ahead. I'm gonna actually just scooch this over a little bit. Let me just check real quick. Okay. All good on, comments and everything over here. I'm just gonna rewrite this equation, and then we're gonna solve for y. So, the first step is to get rid of this entire x term. So the way that we're gonna do that is by subtracting the whole thing, minus 10x. Because this 10x is positive, we want to subtract it in order to, get rid of it over here on this side. So we're left with -3y equals. Now on this side, you might be tempted to write it as -15 minus 10x, which is totally fine. It's not incorrect, but we do want it to be in this format with the x term first and then the constant. So I'm actually going to flip these around and write -10x minus 15. As long as you keep the sign, whatever sign is in front of each term, as long as you keep that in front of each term, then you can do that. You can switch them around. All right, and then our last step here is we still need to get this y by itself. So we're going to divide by -3. And that means every term gets divided by -3. So that cancels out over here, leaving us with y equals, our negatives are going to cancel out. So I'm just going to write this fraction as 10 over 3 x, and then -15 divided by -3 gives us positive 5. So now we have it in that slope-intercept form. So I'm going to start with that y-intercept of positive 5. So that's going to be up here. And then our slope is 10 over 3, so we have a rise of 10 and a run of 3. Now, where my y-intercept is, I don't really have room to go up 10 units. So, actually, the way that it was written here is, kind of perfect because a -10 over -3 is the same thing. So that means I can go down 10 units, down here to -5, and then to the left 3. So if you change the direction of one number, you have to change the direction of the other number as well, because we do want this to wind up being a positive slope. So let's see. So we're gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we're gonna go to the left, 1, 2, 3. And so you can see that when I connect these 2 points, it is going up as we go to the right. So I do have that positive slope going up and to the right. So we're good there. And that's graphed. We're done with that one. Let's take a look at this next one. I chose this next one because I wanted to show you don't always have to convert your standard form into slope-intercept form. With this first problem that we did on this page, I did want to convert it into, slope-intercept form because I could tell that 15 or -15 wasn't evenly divisible by both 3 and 10. So that's why I chose to change it into slope-intercept form. But on this next problem, -6 is evenly divisible by -2, and we don't have a number here, so again, that's an understood 1. So -6 is divisible by 1, -6 is divisible by -2. And here's why that's important. We can graph lines by both the y-intercept and the x-intercept. As long as we have 2 points, then we can graph a line. So think about our y-intercept. Wherever we have a point, let's pick a point along this y-axis, like let's say right here at 3. Let's think about what that coordinate is. This coordinate is 0, 3. Let's pick a different point. This point right here is 0, 1. Let's pick this one. This one is 0, -4. What do all of these points have in common? The x value is 0. So that means if we substitute out this x and place it in 0, that will give us our y-intercept. Same thing if we go for the x-axis. Along the x-axis, if I put a point here, this coordinate is 4, 0. If I put a point here, this coordinate is 1, 0. This coordinate is -5, 0. So again, what do all of these have in common? They have a 0 in the y placement of the coordinate. So if we substitute out y for 0, then we can solve for x in the x-axis, sorry, the x-intercept. So that's what we're going to do. So let me rewrite this over here. So we've got x minus 2y equals -6. I'm going to substitute out this x for a 0. So 0 minus 2y equals -6. That just kind of goes away. We can divide by -2. Oops. Divide by -2, and y equals 3. So then that is our y-intercept. Now let's do it again. X minus 2y equals -6, but we're going to sub out y for 0. So x minus 2 times 0 equals -6. 2 times 0 is 0, or -2 times 0 is 0, so that's just going to cancel out. So we get x equals -6. So then that is our x intercept. So we have 2 points. We can graph this line. We don't need to know for this particular problem, since they're just asking us to graph it, we don't need to know the slope. We can figure out the slope pretty easily, but we don't need to know the slope. We did need to know the y-intercept for this particular form of graphing. So this one's a really great one to use if both of your coefficients for x and y can go into the constant on the other side. If that constant can be divided evenly by those both coefficients. This is a great method. Okay, how are we doing on time? I think we're doing okay. do want to get into how to write the linear equations from graphs. I think we'll have time to do that. I've just got a couple for us. So we're going to write these in slope-intercept form. I think it's going to be pretty easy to figure out. So what do we need for slope-intercept form? Y equals mx plus b. We need the slope, which is m, and we need the plus b, which is the y-intercept. So just looking at the graph, I can see that the y-intercept is right here at 3. So I know that this part, y equals mx plus 3. So I can substitute in that part. The y and the x are going to stay y and x. We're not replacing y and x for this when we're writing this equation. We're only replacing the m and the b. So now the next step is to figure out what the slope is. So we talked about this last week, how to find slope from a graph. So we need to find another point along this graph. I like to call them pretty points. I can't remember where I've heard that from someone. Like I didn't come up with that myself. But a pretty point is where the graph goes through the grid lines perfectly. So that's what I refer to as a pretty point when I'm talking to my students about it, because like this, we can see that this is close, but it's not going perfectly through that those two grid marks, but this one is. And then for our slope, we can just simply count. So how many units do we need to rise up? And then how many units do we need to run over? So for the rise, we've got 1, 2, 3, 4, 5. For the run, we've got 1, 2, 3. So then our slope is 5 over 3x plus 3. We don't need to simplify anything. That's already simplified as much as possible. And we are going to leave it as improper fraction. Okay, let's go on to our other problem over here. So we've got, just going to write out y equals mx plus b again. Let me shift this over a little bit. And let's start with the y-intercept. Well, it's actually going through right at the origin, right? So this is going to be a plus 0. Y equals mx plus 0. Now, we don't normally write plus 0. I'm going to leave it there just for now. But whenever we have a y-intercept of 0, it just gets left off of the equation itself. But let's use that point to help find our slope. So again, we're looking for a pretty point. So I'm just going along this line. It looks like it's not until we get way up here, up to the very top of the graph, or we could use this one down here. I'm going to use this top one. So our rise is 1, 2, 3, 4, 5. And then our run is 1, 2, 3. But because we went backwards, we went to the left. It's a negative 3. Also, we can see that the slope is going down as we go to the right, so that's going to be a negative slope. So then that means our slope is negative 5 over 3x plus 0. But again, we're just going to leave that plus 0 off. So this is really how we would write this equation. All right, and then our last one, I wanted to include something a little different, something that I know kind of tends to throw students off a little bit. So we talked about this on the previous page, a horizontal line, and it is going through the y-axis right here. So since it is touching the y-axis and it's not touching the x-axis at all, that means that y is the only variable that's going to be involved in our equation. And then it's just going to be y equals, and then right where it's going through that y-axis. So that is, it looks like at -1. So y equals -1. There's our equation for that one. So that has a slope of 0. So again, we could write it as y equals 0x minus 1. But again, whenever we have 0, we usually just kind of leave it off. It's more simplified this way. Y equals -1. Okay, great. Let's take a quick little break. I'm going to come back. When we come back, we're going to do our algebra 1. Show you what that's going to look like. We've got our Algebra 1. We're writing the systems of equations. This one is a really challenging skill for students to take it from word problems and actually write out and solve systems of equations. So let me give me a second to check the chat and see where we are with all of that. Okay, I think we're good there. All right, so let's go ahead and get started with our Algebra 1 section. Hopefully, we'll have enough time to do these because sometimes they take a little bit of time to get through, but we'll do our best. All right. Also, if you have joined me since I began, please say hi in the comments. I would love to hear from you. And let me know what you're working on. If you are in pre-algebra or algebra 1, then let me know what you're working on at school because I would like to kind of curate what I'm going over during these lives to match up with what students are doing at school. So this is a lot of my Algebra 1 students I'm working with now are working on systems of equations. So that's why we're starting here. All right, so let's take a look at this first problem. Find the value of two numbers if their sum is 12 and their difference is 4. So a lot of times just the wording is just a little bit mind-boggling to students when they're first learning systems of equations in the first place, but then word problems are just, I feel like, are almost always those types of problems that um, always feel a lot harder. So we're going to dissect it together. So we've got the value of two numbers. So I'm going to call those two numbers x and y. I'm just going to use those two variables to represent my two numbers that I do not know. What are they telling us about these two numbers? What is true about these two numbers? One thing that's true is that their sum is 12. So that means if I add x and y, it's going to equal 12. X plus y equals 12. Okay, easy enough, right? And then the other thing that they tell us is true is that the difference is 4. So that means that x minus y equals 4. Now, with subtraction problems, a lot of students kind of get freaked out a little bit because it's like, we know that you can't just interchange numbers for subtraction like you can with addition, right? Like, for example, 2 plus 3 equals 5 and 3 plus 2. If I were to write this as a subtraction problem, that wouldn't exactly give me the same answer, right? But with systems of equations, because we don't know either number, it does not matter. X or whatever variable that you put first here for the subtraction problem, X is going to take on the role of the larger number. So we don't have to worry about that too much. All right, last week we talked about how to solve systems of equations. So I feel like for these problems, this first part is the hardest part, just writing down the equations. What are the equations? And then once we get here, then we know how to solve. Because we're not being told which method to use, I'm going to go ahead and use the elimination method because my y's right here are one is positive and one is negative. So if I do my big super addition problem, then those y's are going to cancel out. So let's see what we get here. So 2x equals, and then 12 plus 4 gives us 16. And then we're going to divide by 2, divide by 2. And so then x equals 8. So right there we have one of our numbers. And then I can choose either of these two original equations, x plus y or x minus y, substitute in 8. Remember, we don't have to use elimination again for that second variable. We can just then fall back on the substitution method. And I'm going to go ahead and choose this first equation. So it's going to be 8 plus y equals 12. Subtract 8 from both sides. So y equals 4. And that does work here too, because if x is 8 and y is 4, their difference is 4. So those are 2 solutions. And then, a lot of times, we'll want to write that as a coordinate pair as well. So, you can either write that X and Y and write what they both equal, or you can write it as a coordinate. All right, let's see what we've got here. Number 2, the difference of 2 numbers is 3, their sum is 13. Find the numbers. Very similar. I wanted to start off with some of these that are a little bit more simplified, not so complex. So again, we have 2 numbers. So I'm going to use X and Y again. The difference of the 2 numbers is 3. Okay, so difference means subtract. So X minus Y equals 3. Their sum is 13. Great. X plus Y equals 13. Now you could always guess and check with these types of problems as well. But there is, the system of equations does help a lot, especially once we do get into those more complex problems. Again, my y's are opposite signs, so I'm just gonna do one big addition problem. Let me speed this up. So 2x equals, our y's are canceling out, and this equals 16. We have the same answers, okay, so 2, we're gonna divide by 2, so x equals 8. Right, and then I'm going to, again, choose one of these to, substitute in 8 for x. I'm gonna choose the addition problem. So x plus y equals 13. I replaced x with 8, subtract 8, almost the same answers. So y equals 5. So those are our solutions for this one, and then as an ordered pair, we've got 8, 5. All right, let's get into some that are a little bit more challenging. I chose these 2 problems because they are a very typical system of equation word problem. So let's read through the problem and then we can dissect it together. The school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of 30, excuse me, $38. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. Find the price of a senior citizen ticket and the price of a child ticket. Okay, so this is a very common system of equations type of word problem where you will have the number of something and the amount of something. That's what our 2 different equations are going to represent for this particular problem. One of the equations is going to be about the information about the number of, in this case, tickets. We're talking about different types of tickets. The other equation is going to be the amount, the price of those tickets. So, actually Actually, hold on. No, that's, I think I was reading this wrong because they gave us 2 different scenarios. One scenario has us with 3 senior citizen tickets and 1 child ticket, and they do give us the total of $38. And then the second day, we'll do this in a different color. The second day, they gave us the total of $52 and they told us how many of each ticket. Okay, so both of our equations are actually going to be, look very similar to each other. We're just gonna have different numbers substituted in. The other thing that I wanted to mention is that, a lot of times students don't know what to assign variables to. They know they need 2 different variables, but they don't know what those variables stand for. So an important part of writing systems of equations is just identifying what does your X and Y mean? What does that represent? And you can use whatever variables you want. I'm just going to use X and Y. The question or that last sentence will help you determine what your variables should stand for, because your variables are the numbers that you don't know and that you're trying to figure out. So we're trying to figure out the price of a senior citizen ticket and the price of a child ticket. So that's what our 2 variables are going to represent. So let's say X is going to represent a senior citizen ticket and Y is going to represent a child ticket. Okay. All right, let's set up our equations. Let's go back to purple since I have that underlined here in purple. 3 senior citizen tickets and 1 child ticket for a total of $38. So we know that the amount, the number of senior citizen tickets that we sold is 3. So I'm gonna make a little bit of an edit here. X represents the senior citizen ticket price, and Y represents the child ticket price. That's an important distinction I should have said before. So 3 times the price of the senior citizen ticket plus 1 times the price of a child ticket is going to give us $38. And then in green here, we know that it's going to equal 52. And again, we have 3 senior citizen tickets, so 3 times the price of a senior citizen ticket plus 2 times the price of a child ticket gave us $52 total for that day. All right, so now we get to decide, are we going to use substitution or elimination? I really don't like graphing for these types because it doesn't guarantee an exact answer, like this does, especially when we're talking about money. We could have cents involved, and so I just like to stick with substitution or elimination method. I could either multiply one of these by -1, and so that my 3 x's will be cancel out with each other, one will be negative, one will be positive. Or I could solve this first equation for y since I have just one y here and then substitute in. I think maybe that's what I'll do, especially since, we didn't do substitution in those other 2 problems. So I'm just gonna rewrite this, 3x plus y equals 38. And then I'm gonna subtract 3x from both sides. So y equals 38 minus 3x. I'm not really worried about setting it up in that format of y equals mx plus b because I'm just using this for substitution. So I'm going to substitute this all in for y in the second equation. So let's go ahead and do that. I'm gonna move this over, give myself more room. So we've minus 3x, 2, and then we're gonna distribute this 2. So 3x plus 2 times 38 is 60 and 16, so 66 minus 6x equals 52. And then I've got like terms I can combine. That gets negative 3x plus 76 equals 52. We're gonna subtract 76 from both sides. So negative 3x equals, this is going to be so what I'm doing in my mind right now, I'm flipping these 2 and subtracting, and then I know my answer is gonna be negative because my 76 is negative. 6 minus 2 is 4, 7 minus 5 is 2, and then I'm going to divide by negative 3, so x equals 8. So it looks like our senior citizen ticket price is $8. And then we can use substitution, by substituting that 8 into either of these equations. I'm gonna go ahead and use this top one. So x plus 3 times 8 plus y equals 38. 3 times 8 is 24 plus y equals 38. Subtract 24 from both sides, and y equals 14. So that is the price of a child ticket. Okay, there we go. Let's see how we're doing. All right, let's go on to this next problem. Check and see what else I have prepped for us. I think I have one page. So I don't think we have time to do all both of these, so we're gonna pick one right now. Um, this one is very similar to the one that we just did. We've got small boxes of oranges and large boxes of oranges. We have 2 different sizes of oranges, and in the end here, it says find the cost of each of one small box and one large box. So it's very similar to the price of the ticket prices. So let's go down and try this one instead, just to give you as much variety as possible here. So the senior classes at High School A and High School B planned separate trips to New York City. The senior class at High School A rented and filled one van and 6 buses with 372 students. High School B rented and filled 4 vans and 12 buses with 780 students. Each van and each bus carried the same number of students. How many students can a van carry? How many students can a bus carry? So, when I'm working on these types of problems with students, they might be tempted to use the variables A and B because they say 2 different schools, and so then that must be our 2 different variables. However, remember that these last sentences, in this case, it's 2 different questions here, that's going to help you know what your variables are. The variables should represent how many students a van can carry and how many students a bus can carry. So we could use B and B if we wanted to do that. Go back to our X and Y. We just need to make sure that we understand what each of those variables represent. So let's say that V, it represents the number of students in each van, and B represents the number of students in each bus. Okay. Now, the high school A and high school B is important, but that is going to be our 2 different equations, right? One equation is going to represent what happened for high school A, the other equation is going to represent what happened for high school B. So let's go through and see if we can write some of those equations. The senior class at high school, so we're talking about high school A, filled 1 van and 6 buses with 372 students. All right. So if we're talking about students in each van, 1 times the number of students in each van should give us the total number of students in the vans. And then B times 6, because B represents the number of students in each bus, that should give us the total number of students in each bus. When we put all of that together, it should give us our total number of students that went on the trip. So that means we have 1B plus 6B equals 372. All right. And then let's use green for the other one. For high school B, we've got 4 vans and 12 buses. So they have more students. They have more of each type of vehicle. So then for high school B, we have 4 times the number of students in each van plus 12 times the number of students in each bus equals 780. Great. All right, so then now the hard part's done. Writing the equations is the hard part. Now we just have to solve. We get to choose substitution or elimination. I'm gonna go ahead with substitution again because this first equation here, that's gonna be pretty easy. I can just subtract 6b from both sides, so I get v equals 372 minus 6b. And then that's what I can substitute in for v in this second equation. So we've got 4 times 372 minus 6b plus 12b equals 780. So remember last week when we were talking about solving these types of equations, the goal is always to get an equation with just one variable in it so we can actually solve it. All right, 372 times 4. I don't happen to know that one off the top of my head. So let's figure out. Okay, so that is 1,488 minus 24b, I'm just distributing this 4, plus 12b equals 780. I'm just trying to finish this last problem up before it's time to go, because I do have another student right after this. So, negative 24b plus 12b is negative 12b equals 780, and then we're going to subtract 1488 both sides. So again, in my mind, I'm just flipping 88 minus 780. So that's going to give me 708 net. And then divided by negative 12. Trying not to use a calculator, to be honest, that's what I would normally do. So 708 divided by 12, that goes in 560, and then 108 is 9. Okay, great. So B equals 59. So the number of students that can fit in each bus is 59 students. And then I'm going to use this first equation. That one seems the easiest. So B plus 6 times 59 equals 372. So let's see what 59 times 6 is. See, that's 54. And then 35. So V plus 354 equals 372. Subtract 354 from both sides. These do take up a lot of room on paper, just FYI. Okay, so then it looks like we have 18 once we subtract that. So for the van, we've got 18 students for the van. So that's 59, and the van is 18 students. All right. So we figured out how many each type of vehicle can carry. Thanks so much for joining me. I hope that this was helpful for you. If you're watching this later on, then please leave me a comment below. Don't forget to like and subscribe. That does really help me a lot to continue making these videos. And if you have any other suggestions, please let me know as well. I do offer one-on-one tutoring. I do have a couple of spots open in my schedule, so let me know if you could use a little bit more support in math. I tutor students from second grade all the way up through high school level, algebra, geometry, algebra 2, statistics. So if any of that could be helpful for you, please feel free to reach out. Thanks so much for joining me tonight. I'll see you next week. Bye.